aoc2022, and this is a demo of using my Galaxy S6 Lite tablet to do advent of code in Emacs. So the first thing we need to do is we need to go to the advent of code site. I have logged in, and we're going to look at the puzzle problem. And today we're doing the day one of the year 2022. All of the years back to, I think, 2015 are still there. Anyway, I'm going to summarize this. You can read it on the site. But basically, we are having elves that are carrying food. Each elf carries different items of food. The elves' items have a certain number of calories, and these numbers that are up here, those represent the number of calories. So the first elf has 3 items with 1,000, 2,000, 3,000 calories. The second elf only has one 4,000 calorie item. The third elf has 2 items, 5,000, 6,000 calories. The next elf has 3 items, and the last elf only has 1. And so the job of this first puzzle is extremely simple. We need to add up the number of calories that the elf has that is carrying the most calories. So it shows us for this little sample up here that the first elf has 6,000, 1, 2, and 3 added together. Second has 4. Third has 11, 5, and 6. 7, 8, 9 goes to 24,000. And the fifth elf has 10,000. So the elf that has the most calories is the fourth elf, and he has 24,000. So we're going to try to solve, and one of the unique features of advent of code is you get, as a particular user logged in, you get your own unique puzzle input. So this is going to be our puzzle input. So we have bigger bunches of elves with bigger sets of numbers that we're going to have to do the same operation on. So we're going to leave that there for the moment. We're going to start up Termux. Termux has, among many things, an Emacs. So here's our Emacs. And I'm going to say I want to open up a file, Control X, Control F, and I'm going to call that file aoc2022-01 for the year and which day, and I'm going to have it be of type EL, which stands for Emacs Lisp. Now, in my .emacs file, I have a definition of a function that allows me to fill in a template for each of these things. So I'm going to invoke that right now by typing meta : which gives the eval prompt down at the bottom. And what I'm going to type in is the expression AOCA for the advent of code, activity 0 for the year and 1 for the number. And what this is going to do is it's going to generate a skeleton of code and insert it into the buffer. So if we look at the skeleton of code, you can see that we've got some defvars. Defvars define variables. The first thing is the defvar itself. That's next is the name of the variable, and the third thing is the value. All of these values are empty strings to some degree. Then we have these 2 defins. Defin is how you define a function, and this is going to be the function that computes the part 1 answer, and then below it is the one that computes the part 2 answer. And then these commented outlines in orange are commented out invocations, and the invocation is on both the sample input data, which is usually contained in the statement of the problem, and also on the real input. So the first thing we need to do is we need to get the stuff from the website. So here we are, going back to here. We're going to just say, basically long press, select all, copy, and then go back to Termux. And so where it says aoc2022 input at the top, I'm going to type there, I'm going to long press and say paste. So now that's in there. But that's just text in a buffer. So we have to evaluate that so that the variable has that value in it. So Control Alt E goes to the end of the containing expression, and Control X, Control E evaluates the expression that's ahead of us. So that is going to give us our input value, and in fact, if we look down here further, you'll see that these functions both take input string, and the invocations here refer to those variables. The second one, which is doing the real input, refers to the variable we just filled in. So to get the sample, we go back to this. We're done with this. We don't need it anymore. We can say do the same thing here to get the entire text. Select all, copy back to Emacs. I'm going to start with a different buffer. Text. Doesn't matter what it's called. I'm going to paste into here. Because there's two things that we have to do in general. Because we're saving this text in a Lisp string, Lisp strings have a couple of restrictions. One is that if you have a backslash anywhere in the string, it has to be doubled. And it has to be quoted by backslash. And if you have a double quote in the string anywhere, you have to quote that as well by backslash double quote. That's because a Lisp string starts with a double quote and ends with a double quote, and if you had any interior double quotes, it would get confused. So we're going to actually check to make sure that we don't have such things. We could, if we had such things, we'd do a block replace, to fix it up before we put it into the string variable. So we're going to check that by saying Control R for reverse search. And the thing that we want to reverse search for first is a backslash. There's no backslash. If there was a backslash, we'd go up to the beginning of the file and replace every backslash with 2 backslashes. Since there isn't one, you can now go and search for double quote. If I can find double quote, there it is. And we can also see that it says failing search backward for double quotes. So there are no double quotes in this at all. So we didn't have to do this. I'm in the habit of doing this because in the general case, many times in the advent of code, puzzles, there have been quotes and double quotes and backslashes that we've had to fix up this way. So one of the variables was the actual text of the problem. So let's go. This is the end of the text of the problem, so I'm going to say Control Space to push the mark there. I'm going to say go to the beginning of the buffer, and I don't really want all of this preceding text. I just want from where it gives the day one and the name. I'm going to Control W to cut that out. Control XB to go back to my thing. And where it says Part 1 problem, right here, I'm going to Control Y to copy that in. So now we can actually find the sample, which is described in here, and that goes from here. So I'm going to say Control Space to here, Control X to highlight it, and this time I'm going to do meta W because I want to leave it in here, and then we're going to go to the sample and Control Y. And this one we're going to have to do the same thing we did before, namely Control Alt E to go to the end of the expression, outwards to past the end of the expression, and Control X, Control E to evaluate it. So now that variable has a value, and I'm going to save the file just because. So we're also going to have to do Control Meta F, Control X, Control E. So we need to evaluate that expression, which says load the Common Lisp compatibility package. This brings us the loop macro and setf and a bunch of other macros that I use. We're also going to do Control Meta F, Control X, Control E because that will set debug on quit. This means is a useful thing if our function is looping or something. If we type Control G to abort it, instead of just aborting it and throwing away all the state, it actually goes into the debugger at the current point of whatever's executing, and you can poke around and look, and in fact continue if it's making progress and it's just being slow. So with our input, so in the orange parts down here, you'll see we're invoking this function that we're about to write, both on part 1 sample and on the real input. So we know what the answer is for the sample. It tells us 24,000 is the total of the most ELF. So how are we going to do this? So I always start out 90% of these functions that I write for Advent of Code are just going to be loop macros. So loop lets you define a bunch of clauses, which are just symbols. So there's no extra syntax, there's no parentheses, there's no nesting that is part of the loop. So I'm going to say loop with elves, because we have a single string, which is all of those lines of characters, with the new lines included. But the groups of elves are separated by 2 successive new lines, namely a blank line. So I'm going to say loop with elves equals, and we're going to use a built-in Emacs Lisp function called split string. If I can split string. Oops. Hitting these little chiclets is sometimes hard. Notice when I'm positioned after typing a split string, at the bottom it tells me the arguments, namely a string which I need, and then 3 optional arguments. The string that I'm going to split is input string, which will be either my given puzzle input or the sample input. And the first optional argument is called separators, and that's a bunch of separators to use to split it up. The default is just white space, but in fact I need it to be something different. I need it to be 2 successive new lines, so I can split by the I'm doing this in a slightly convoluted way so that I don't have to switch back and forth between these various panels in the keyboard. So I'm splitting by 2 successive new lines. \n is a way to notate a new line. I'm going to go to the end. I'm going to close that parentheses. Notice it flashes the corresponding parentheses, so I always know what I'm closing. So the width variables are there for the duration of the entire loop, but you can also do 4 variables, which are updated each iteration. So for elf equals, and now what we want to do is for each elf we want to get one of these. So split string returned us a list, and each element of that list is the substring, before the delimiters, and the delimiters have been removed, the separators. So we're going to have, some number of numbers followed by new lines, separated by new lines as each substring for the elf. So we're going to have to split again. So we could say for elf, actually a better name would be for elf strings, to make it clear that what we're getting is the set of strings for a single elf. This time we're going to split string. Oops, sorry. We're not I'm getting ahead of myself. So we want elf string, sorry, we want, yes, elf strings is going to be that, but we do want for elf. So for elf in elves. So we're going to go stepping down the input string. So each time through the loop, elf will get the next element of the list that we got in elves. And then elf strings is going to split string elf. And this time we're splitting by just a single new line. But this isn't going to help us very much, because what we want to do is we want to treat these so that now we will have individual strings that have the numbers of the calories, but they'll be strings, not numbers. And Lisp doesn't do arithmetic on strings. So we're going to have to turn them into strings. So for elf total calories equals. So what we're going to have to do is we're going to have to add up something. Now, one of the cool things about Lisp is that because it uses the operator as the first element of the expression, and all of the rest of the elements of the list that is the expression are the arguments, you can do things like apply plus to a whole raft of numbers. So that's exactly what we're going to do. So apply the function plus, and what we want to do is we want to take that list of elf strings and turn each of those elf strings into a number. So we can do that in many different ways, but one way is to call the function. This is a common Lisp function, map. And the first argument of map is what type of sequence we want to get back. I want a list. And the next argument for map, see, it says type function sequence is the function that we want to apply to each element of the list, collecting the answers of applying that function to each element into whatever sequence type we said. So the function I want here is one of the common Lisp functions, parse. Now in common Lisp, it's just called parse integer, and in older Emacs and the common Lisp compatibility package called it that, but for reasons that escape me, they decided to change it. And then what we want to pass is the actual sequence that we're going to apply this function to each element of, which is namely elf strings. So this is going to give us the total elf calories. And since all we want the function to do is return the maximum total, we can just use the maximize keyword, elf total calories. And what that does is it tells the loop macro to arrange it so that it basically does the comparison and testing for keeping the maximum value for you, and then returns that maximum value as the value of the entire loop expression. So we're going to finish off, and so that's done. Control Alt E to get out to the end of the expression. Control X, Control E. Might as well save while we're here. So we can move down to here to this sample part. and I'm going to control space to mark, push, set the mark here, and control meta B to go backwards over the expression, meta W to copy it, control E to go to the end, control U, meta colon. Now meta colon allows us to evaluate an eLisp expression, and if you just call meta colon, the value will show up in the mini buffer, that line at the bottom. But if you control U meta colon, the value will be put into the buffer. So I'm just going to yank back the expression that I just copied. And notice we get the 24,000, which is the right answer for our sample. So in theory, we should be able to do exactly that. Meta control B, meta W, control E. Now, typing this is much slower on the tablet than it would be on a real live keyboard. I'm a touch typist and pretty fast on that. But doing this on a tablet has the advantage that I can do it under the covers at night without bothering anybody making any noise. So that's a significant advantage. Control U, meta, colon, control Y. And so that's the answer. I'm going to control X, control S. We're going to take that again, control space, meta B, meta W to copy it. So now we're going to go back to the thing and see if we're right. So we're going to paste that in there. Submit it. And we got the right answer. So now we're going to go to part 2. So by the time you calculate the answer, they've already realized that the elves carrying the most calories of food might not even have enough. So what they want to do is they want the sum of the top 3 elves. So there's multiple ways we could do this. So I'm going to actually, first, before we do that, I'm going to copy the part 2 problem. So actually, let's just select all, copy, go back here, and go back to the other buffer that I had the text in. Go to the end. If I can find that. And paste that in, because we really only want a small part of it. So I'm going to go to here. So this is the part 2 problem, which we can paste into here. And so now we need the function. And it's going to be very similar. So we're just going to copy the first one. Control Alt U goes to the up a level. Control space. Control meta F goes forward, meta W copies. So here's the original one. So instead of maximizing elf total calories, we just want to collect them. Meta D. Collect. So this is going to return us a list of the totals for all of the elves. And now we want to sort that list so that we have the highest 3 at the beginning, and then we want to basically add those. So we're going to apply plus 2 another loop but this loop is only going to repeat 3 times for calorie value in, and this is going to be a list, but this is going to be a list that's sorted. So we're going to take the list that comes back from the inner loop and we're going to call sort on it. So control meta F goes forward. Sort takes a sequence, namely this loop result that's going to collect all the categories, and it takes a function to use to compare elements of the sequence for doing the sorting. So that's going to be just the greater than function. And so then we close off that guy. So that's closing off the sort. And we want to collect these values, but we're only going to collect 3 of them. And that is going to close that one. And so those 3 values are what we're going to add together. So we just need another parentheses here, and I think we're done. Now, control meta A goes to the beginning of a definition. Control meta Q reindents it. So now we can see the structure a little bit more clearly. Of course, we also see that I mistyped collect. So let's try it. Control Alt E to go past it, Control X, Control E to evaluate it, Control X, Control S to save it, Control space, Control Alt B, Meta W, Control E, Control U, Meta colon, Y. Oops. So my template calls the part 2 sample by default. We didn't have a part 2 sample, so we're gonna just say Q, change this to say part 1 sample. Control U, meta colon, Control Y, and we'll go back Control R to 2 and delete that, make it a 1. So that's 45,000. Is that what they said in the part 2 problem that we should get? Yep, so that's the right answer for the sample. So now we're going to do the same thing on the real life data. Control space, Control meta B, meta W, Control E, Control U, meta colon, Control Y, Control space, meta B, meta W, go back to there, paste it in, and say submit. And so we got the right answer. So that's an example of doing advent of code purely in eLisp, purely on an Android tablet, Hope that was enjoyable.